Your Auth0 login flow is working, but now you need to actually test it with a real client connection. We'll build a complete FastMCP client that handles the OAuth dance automatically, opening the browser for Auth0 login, securing the token, and making authenticated tool calls. You'll see exactly how the client-side pieces fit together to verify your server's authentication is working end-to-end. From FastMCP Import Client. Import Auth0. Async def main. Hash the client will automatically handle Auth0 OAuth flows. Async with client. http://localhost 8000/MCP auth equals OAuth as client. Hash first-time connection will open Auth0 login in your browser. Print authenticated with Auth0. Hash test the protected tool. Result equals await client, call tool, get token info. Print Auth0 audience, result audience. If name equals main. Auth0 run main. This demonstrates the OAuth proxy pattern for integrating third-party identity providers with custom services. The approach uses Auth0 as an OpenID Connect provider while abstracting its dynamic configuration behind a standardized interface, allowing your application to handle authentication without direct coupling to Auth0's specific implementation. What makes this distinctive is the separation between the authentication flow, handled by Auth0, and your application logic, protected by FastMCP, with the proxy layer bridging the two. The pattern works by delegating authentication to Auth0 while maintaining a clean boundary between identity management and business logic. When a client connects, FastMCP redirects to Auth0 for login, receives the token, validates it against Auth0's configuration, then issues a local JWT for subsequent requests. This design keeps your tools stateless regarding authentication, as the framework injects verified claims into each request context automatically. This approach solves the problem of integrating enterprise-grade authentication without embedding provider-specific code throughout your application. It's particularly valuable for microservices, AI tooling, or any scenario where you need to secure APIs without managing user credentials directly. The trade-off is added complexity in initial setup, but the result is a maintainable system where authentication concerns remain isolated from your core business logic. Let's break it down line by line. From FastMCP Import Client. Imports the client class from FastMCP, the primary interface for connecting to MCP servers. This handles all low-level connection management, authentication flows, and RPC communication with the server. Import Auth0. Imports Python's built-in Auth0 library, enabling asynchronous I/O operations. This is required for the async await syntax used in the FastMCP client connection and tool calls, allowing non-blocking network requests. Async def main. Defines an async entry point for the script. This is required because FastMCP's client uses async I/O, and the event loop needs an async function to execute. The pattern ensures non-blocking network operations while maintaining clean resource handling. Hash the client will automatically handle Auth0 OAuth flows. Async with client. http://localhost 8000/MCP auth equals OAuth as client. This establishes an authenticated connection using FastMCP's OAuth flow handler. The context manager pattern ensures proper connection cleanup after use, while the auth equals OAuth parameter triggers automatic Auth0 authentication in the browser. This is the standard way to initialize secure client sessions with FastMCP servers. Hash first-time connection will open Auth0 login in your browser. Print authenticated with Auth0. This print statement confirms successful Auth0 authentication. It serves as a visual cue that the OAuth flow completed, and the client now has valid credentials for protected API calls. The comment clarifies this is triggered after the browser-based login completes. Hash test the protected tool. Result equals await client, call tool, get token info. This invokes the protected get token info tool via the authenticated client, demonstrating secure API access. The await handles the async operation, returning the decoded Auth0 token payload for inspection. This pattern verifies your OAuth flow works before using other protected endpoints. Print Auth0 audience, result audience. This extracts and displays the Auth0 audience claim from the token info response. The audience value verifies which API the token was issued for, confirming proper authorization scope. If name equals main. This is Python's standard entry point guard. It ensures the async event loop only runs when the script executes directly, not when imported as a module. Without it, importing this file would trigger unintended server connections. Auth0 run main. This boots the async event loop and executes the main coroutine. Required for running async code at module level, it handles the event loop lifecycle automatically. OAuth flow pattern. This client demonstrates FastMCP's built-in OAuth integration, where the async context manager handles the entire authentication flow automatically, from browser redirect to token caching. The first authentication always opens a browser window, but subsequent runs use the cached token silently. You now have a production-ready pattern for securing FastMCP servers with Auth0, GitHub, Azure, or any OAuth provider.
The client that never asks for permission already has it.